Why is the Carnot cycle so important for thermodynamics? Imagine a machine so perfect that it sets the ultimate standard for all heat engines. That's what the Carnot cycle does in the world of thermodynamics. It's like the gold standard for efficiency. When we talk about heat engine principles, thermodynamic systems, and cycles, the Carnot cycle is the benchmark that helps us understand the limits of what engines can do. It's not just a theoretical idea. It shapes how engineers design real engines and refrigerators. The cycle describes an idealized engine that operates in a way that no energy is lost. It uses for specific steps to our isothermal processes, which means they happen at constant temperature, and to our adiabatic processes, where no heat is exchanged. First, the gas expands at a high temperature, absorbing heat and doing work. Then, it expands further without heat exchange, cooling down. Next, it compresses at a lower temperature, releasing heat. Finally, it compresses without heat exchange, heating back up to the start. Because these steps are perfectly reversible, the cycle experiences no energy loss like friction or other inefficiencies. That's why it's the most efficient cycle possible. The efficiency of this cycle depends only on the temperatures of the hot and cold reservoirs involved. The bigger the temperature difference between these 2 points, the higher the maximum efficiency. The formula for this efficiency is 1 minus the ratio of the cold reservoir's temperature to the hot reservoir's temperature. This relationship shows that no real engine can surpass the efficiency of a Carnot engine working between the same 2 temperatures. This cycle is important because it sets a clear limit on how efficient heat engines can be. It helps engineers understand how close their real engines are to this ideal. It also provides a way to analyze and improve refrigeration systems by comparing their performance to the Carnot limit. The cycle is fundamental in understanding the second law of thermodynamics and the concept of entropy, which explains why some energy is always lost as unusable heat. In practical terms, even though no real engine can reach Carnot efficiency because of unavoidable energy losses, knowing this limit helps in designing better engines. It encourages operating engines with as large a temperature difference as possible to maximize efficiency. The Carnot cycle is a key idea that connects the theoretical principles of thermodynamics with real-world applications, making it easier for everyone to grasp how heat engines and refrigerators work.